Hi, everybody. Welcome, everyone. This is Desi Vijay. I'm a North-South National team member and the coordinator for the webinars. Glad to see you all here. We have a group of science pros with us and ready to talk to you. This is our 5th pro session. We wish to thank you for all the support and encouragement during all this webinar series. So today we are talking with the science pros, and we are really pleased to have Maya, Abhi, Shobha, Bhagirath, and Kamala with us today to talk to us about their experience and answer your questions. I'm really glad that we are able to make this happen today, and welcome to the exciting webinar. Before I introduce the panel and our special guest, since it's a science webinar, let me start with a strange fact and quiz, as I normally do. Of course, if I know, you all will know this already, or you can easily Google it, just like I did. Anyway, let me ask you this. Did you know that the male seahorses give birth to the young, not the females? I was surprised. Also, we know that trees are the longest living life on the earth. Can you guess the age of the oldest living tree and where does this live? Google it, or we can talk about it later in the program. We have with us the current president of North-South, Dr. Bal Natarajan, with us today. Dr. Bal Natarajan has been supporting North-South Foundation for so many years. In fact, he was the first pronouncer of the first national North-South spelling bee, and also has the distinction of being the first Indian American ever to win the Scripps National Spelling Bee Championship in 1985. He is a medical doctor specializing in internal medicine, sports medicine, hospice, and palliative medicine. I welcome Dr. Balu to introduce the panel to all of you.
Thank you. How are you doing? Panelists, you ready?
You're right.
Okay, so we will go from youngest to most experienced. We'll start with Maya Sriram. Maya is a 9th grader who goes to Basis Independent Silicon Valley. She's been a participant in North-South Foundation events since 2013. She's participated in science, math, spelling, public speaking, and brain bee. She won 3rd place nationally in 2020, 3rd place regionally in 2019, and 2nd place regionally in 2015. She's a part of non-North-South events such as Science Bowl, Science Olympiad, and Biology Olympiad, and she won 3rd place in regional Be the Chemist challenge. She's also won multiple other speech, math, spelling, science, coding, and brain bee contests, as well as stand-up comedy, among others. Abhijit Sambangi. Abhi is enrolled in a 7-year bachelor's MD program jointly hosted by Penn State University and Jefferson Medical School. In college, he co-authored in a publication for Nature Communications after contributing to Alzheimer's and Huntington's disease research. After completing his bachelor's requirements in 2 years, he joined a neuroscience lab hosted by Harvard Medical School and Beth Israel Deaconess Medical Center, working full-time before matriculating to Jefferson this summer in July 2021. In primary school, after placing top 3 regionally and top 10 nationally in North-South Science Bees, Abhi captained his team to win the 2014 Middle School National Science Bowl undefeated. In high school, he won the MIT Boston Brain Bee and placed 2nd in the 2015 US National Brain Bee. In addition, he was a technical design lead for high school entrepreneurship teams that won the 2017 National Lemelson MIT grant and placed 3rd in the 2016 TIE Global's Young Entrepreneurs Competition. Shobha Dasari. Shobha is a 2nd-year student at Stanford University, where she's majoring in computer science. In high school, she conducted biomedical engineering research at a University of Houston lab, through which she was able to publish 2 scientific journal papers. She also completed in the Intel ISEF Science Fair, top 300 Regeneron Science Talent Search Scholar. Shobha has founded 2 education tech startups and hopes to start her own healthcare technology company in the future. In her free time, Shobha enjoys listening to music and podcasts, learning new languages, and trying new ice cream flavors. She's also the author of a book called Hacking Healthcare, which is about using technology to make healthcare more human-centered. That will be published soon. Bhagirath Mehta. Bhagirath Mehta is a junior double majoring in electrical engineering and computer science at Stanford University. He participated in North-South from 1st through 4th grade, placing 1st in Math B Level 1 in 2nd grade. In 7th grade, he won 1st place in the national Be the Chemist competition. In his freshman year of high school, he placed 1st internationally with a perfect score in the Math Kangaroo competition. He was also a national semifinalist for the USA Biology Olympiad and a national semifinalist for the USA Chemistry Olympiad, and participated in the AMC AIME math competitions. He's a part of IEEE and the science newspaper Fascinate. Last year, he led the Stanford trading team and won 1st place in the Citadel Securities algorithmic trading competition at the International Rotman Trading Competition, beating 50 teams from all over the world. He has interned at Amazon and Microsoft as a software development engineer. We don't just have students here, we've got coaches as well. Kamala Vanarsa is currently employed as senior researcher at University of Houston in the Biomedical Engineering department. She did her master's in medical microbiology from Kasturba Medical College in India, and following that at University of Texas at Dallas with a master's in molecular and cell biology. Her research areas mainly focus on autoimmune diseases, cancer, and biomarkers. She has more than 20 peer-reviewed publications and is also serving as a reviewer for journals. She has been actively volunteering, tutoring TMSCA Science and North-South Science chapters. So we have stalwarts from the Bay Area, Boston, and Houston. And Daisy, I will turn it back over to you to let us know who's starting first. I think you've got some presentations ready to go.
Thank you. Thank you, Dr. Paulo. And we are really pleased to have all of you here. Let's invite our panelists to just introduce themselves and talk a little bit. So I'm going to ask Maya, the youngest of the ones we have here, to talk to us. Can you see my screen?
Yeah, I can see your screen.
Okay.
Hi everyone, I'm Maya, and I'll be talking a little bit about my path in science so far. It's very close to ending, of course. I'm in 9th grade, but I want to talk a little bit more about how I got into NSF and other things. Now, just to reiterate about me, I've been participating in NSF since 2013, and I mainly participated in math, science, spelling, public speaking, and brain bee, but I also did a little bit of vocabulary and history last year. And in NSF Science in 2020, in the rankings, I was 3rd place nationally. In 2019, I won 3rd place regionally in senior science. In 2015, 1st place in junior science. This year, I'm part of Science Bowl, Science Olympiad, and Biology Olympiad. Last year, I placed 3rd place with my team. It was a very unusual year, and we got to compete in teams instead of as each person is a separate person, and my team won 3rd place in the regional Be the Chemist challenge. And I've also won multiple other speech, math, spelling, and brain bee competitions, but you're not here to hear about those, are you? So let's talk a little bit more about science. You can move on to the next slide. Now, how did I get started? What brought me into NSF? Well, in 2nd grade, I joined NSF for the first time. I only took spelling and math that year. I was in 2nd grade, so I was like, what is this new thing? I wonder. And I was hearing about all the science awards, and it was super intriguing. So in 3rd grade, I took science, and it was super fun, and I placed because of some school knowledge that I had. And then in 4th grade and in 5th grade, I continued with science. I took a coaching class in 5th grade, and I was able to do pretty well in science. But then in 6th grade, that's when it really got started. I started going to BASIS that year, and I was introduced to the 3 different sections of science: Originally, I had only seen science as one big unit, something that you learn stuff in. But then suddenly I learned that most people split it up into 3 different parts: biology, chemistry, and physics. And I participated in a couple of specific competitions for those sciences at my school. And I was super intrigued by all of it. And then in 7th grade, I had an amazing chemistry teacher. And she taught stuff in such a unique way. I was super interested. She convinced me to participate in Be the Chemist challenge that year, and I didn't go further than my school competition, but I got really interested. And then in 8th grade, I started learning more advanced biology. That was really interesting to me as well. And I participated in Be the Chemist again. That year we did it as teams, and we placed 3rd at regionals, which was really awesome. And currently I'm in 9th grade. I'm only allowed to take 1 science this year. Last year and the years before that, I was allowed to take all 3 sciences: biology, chemistry, and physics. But now that I'm in high school, I can only take 1 of them. I'm taking a physics class, and it has a lot of new concepts that are really fun to learn about. You can move on to the next slide. Well, NSF specific, my journey. Well, after 5th grade, my science knowledge took a huge leap, since instead of taking 1 class called science, I was taking 3 classes: biology, chemistry, and physics. I learned a lot more in all of those classes. And my performance in NSF took a leap as well. And my school taught certain concepts such as molar mass and taxonomy that were very helpful. But even if your school doesn't teach those, there are always ways for you to find courses online, take an NSF coaching class, and learn about these concepts separately. And the science clubs I am in this year, I'm in 3 science clubs actually, and I'm in Biology Olympiad to reinforce my biology knowledge because I'm not taking a bio class. Science Olympiad is more hands-on and specific in that we have events that we participate in with 1 other person, and we take tests and do hands-on things, and there's a lot. It's not the normal kind of test-taking competition that you'd expect, but it's still really fun and teaches you a lot about specific topics. And then Science Bowl is kind of similar to Quiz Bowl, if you've heard of it. They ask you a question and you buzz in and you say the answer. It's that kind of format. This year they changed it to teams because they're changing everything because it's online. Science Bowl is super advanced, but it's invaluable. You should definitely take it once you guys have the opportunity. Next slide. Okay, so some of the resources. Definitely take classes. Most of my knowledge came from school and other classes I took outside of school. Self-studying is great, but at one point you need to know what you need to study, and a coach or taking a class will definitely point you in the right direction. Definitely, you should take NSF coaching classes and study everything that they teach you. There's a lot of invaluable pieces of information in what they teach you there. And then make sure to focus on both the explanation part and the equations and definitions. You can think about how something works on one side, and you need to think about what you need to implement for that thing to work. So you need to focus on both those things, and classes will definitely help you to see what you need to learn. Some of the science competitions you can participate in are, maybe you guys have participated in science fairs at your schools. No, you can participate in Broadcom Masters. It's a science fair, except it's on a larger level. And then there are competitions like the USA Biology Olympiad, the National Chemistry Olympiad, and the USA Physics Olympiad. So those are competitions you should definitely look into if you're interested in maybe 1 or 2 specific branches of science. They're also really, really advanced, but if you are super interested in something, you should go for it. And then Science Olympiad, I talked about that one. Hands-on science events. Science Bowl gives you some science questions. International Brain Bee. That doesn't really fit here because North-South Foundation actually has a separate event called Brain Bee, but there's definitely a lot of science and Brain Bee overlap, and you should look into that as well. And then there are various other smaller science competitions like the Be the Chemist challenge and other little things like that. You can move on to the next slide. Okay, well, I have some links to resources on this slide. These are kind of specific to North-South Foundation's competitions because I assume that's what you're studying for, and there's a lot of other stuff out there for the other competitions. So the syllabi are lists of information that you need to pay attention to and that you need to study to know what topics are going to be on the North-South Foundation test. So you should look at those based on the level you're at and make sure that you know at least a little bit about each of the topics on there. And then there are the McGraw-Hill books. You can look at them. They're textbooks and they're definitely useful. If you read through one of these, I'm sure you'll have all the information you need to ace your science competition. There are a couple of other resources down here like Science Kids quizzes, National Science Board tips and resources. If that one is intended for Science Bowl, but the resources are useful for the senior science. And then there's a ton of information about the science competitions at this NSF link, so you can check that out. You can move on to the next slide. A few little tips and tricks. Don't focus in too much on one topic. Make sure you know some things about all the sciences, because this competition is very broad and you need to know different things from all sorts of different concepts. And then make sure you have a solid grasp on all three sciences. Don't avoid one because it's hard. Again, this is the same thing. Don't focus in too much on one thing. Make sure you know things about everything for now. You can specialize later. Use the syllabus. The syllabus is invaluable. Look at all the terms on the syllabus and make study guides, flashcards, and then make sure you know all the words and that you can explain them to someone, maybe like your parents. That's the best way to learn. Make sure that you can explain something. And then on test day, if you don't know a question, make sure you take an educated guess for that question. You should be able to eliminate some of the answers based on some knowledge that you already have. Try to narrow down your options. That's all the information I have for you about my path in science and the competitions today. Thank you guys for listening.
Thank you, Maya. You want to go through the other one, or we'll finish with the others and come back?
I think it's best if we go through the other one really quickly because I have to drop out at 10.
Yeah. Okay.
Well, cloning is actually one of the topics that got me really interested in biology and chemistry, and I wanted to introduce you guys to cloning today because I think it's something that intrigues a lot of people, but not that many people really know what it is. So what is cloning? Now, where have you guys heard the word clone before? Maybe in a movie like Star Wars, where they had the Clone Wars. Maybe in another movie like The Sixth Day, some show your parents or older siblings watch. Have you guys heard of Dolly the Sheep? Maybe you heard about her in the news or from your parents or something like that. The sheep, who's this exact copy of another already living sheep. The sheep can think, the sheep can make noises, the sheep can eat. It seems strange. How can we create an organism like that? It's by a process called cloning. It's creating an organism that is the exact copy of one that already exists. Like, for example, a clone of you would be exactly the same as you. They look the same as you, they eat the same way, they walk the same way, they talk the same way. Now, there are 3 types of cloning. This is where it gets interesting and a little bit complicated. There's gene cloning, reproductive cloning, and therapeutic cloning, but they all have the same concept, which is duplicating something that is already living to create another new living thing. I can talk about those 3 different types later. Now, you might have heard this somewhere in the news, ethical repercussions to cloning. What does this even mean? It's fancy words to mean that some people are mad that we have this power to create a new living organism and that we have the power to change that to do what we want. They think it's a living thing. You shouldn't be messing with it this way. But I'll also talk about that later. And now that you're thinking, oh, I can get an exact copy of myself, maybe that exact copy can go to school for me and do my homework. But it costs about $1.7 million to clone someone. So if you're thinking of getting a clone, think again. You can move on to the next slide. All right, let's talk about the types of cloning. I mentioned this, right? So the first type is gene cloning. So basically, when you're born, there's this little material inside us that tells your body who we are. It's DNA. It basically goes, okay, this person is going to have black hair, brown eyes, this colored skin, this kind of teeth, etc., etc. And our body looks at the DNA and says, okay, this is what it's telling us to do, and then it does it, and that's what creates who you are. But if you take that thing that tells your body what to do, and you take a copy of it, and you put it in something that will read it, that or whatever will read it and say, okay, so we got to create this thing. But the thing that's being created is a copy of you, because that material, that DNA, is what created you. So if we put it in another organism that can grow, then it'll grow into an exact copy of you, because that's what the DNA is telling it to do. It'll become a fake you almost. Now, the second type of cloning is reproductive cloning. This is a lot like twins. Instead of just taking this DNA out of you, they take the entire of you when you're really, really small, when you're barely a dot. They take the entire of you and make a copy. And it'll be an exact copy of you. It'll be just like twins. And then there's a third type of cloning, which is called therapeutic cloning. Instead of taking the DNA from you or taking the entire of you and making a copy, they'll take just little chunks of you, little parts of you, and make a copy. And that copy will become anything it needs to be. Like, for example, if you were to, say, lose your nail or something like that, they can take a little chunk of a piece of you, make a copy of that, and then take that copy that they've made, turn it into nail or something that matches you, and they can put it back on. It's a way for you to heal from any injury. They can take a piece of you, duplicate it, and then put that piece where you need extra cells or an extra piece of you. Okay, you can move on to the next slide. Should we clone? Now, this is that thing I was talking about called ethical repercussions. Is it a good idea for us to just create life like this if we have the possibility? I mean, it sure does seem like a great thing, right? We can change. We can take that information that tells you, okay, you need black hair, brown eyes, etc. And we can say, okay, we're going to fix this, and we're going to say you need blonde hair instead. And then we can put it in a new organism, and it can make a copy of you, but with blonde hair instead. That seems like a great thing, right? We can do anything we want with that. And if there's a mistake in the DNA that says, oh, if the DNA reads, oh, this person is only going to come out with one eye, we can fix that and say, no, this person needs two eyes. And that seems like a great thing. We can fix any problem someone might have, like only having one eye. And we can also save lives for people who have been hurt. We can take a little chunk of their body, duplicate it, and put that extra chunk of cells where it needs to go, where they're missing some. And we can fix the problem. Plus, who doesn't want a clone to do homework and this annoying stuff like that for them? But there are still problems. Here's the thing. This whole, you can click this whole thing is really new, and we don't know that much about how it works. So there's always a possibility that when we take the DNA, the material out of our body, and rewrite it saying, okay, instead of one eye, this person is going to get two eyes. We may have rewritten it wrong, and maybe that person will get three eyes. We don't really know yet. And some people think that we shouldn't take the chance of a person accidentally getting three eyes. Also, if we change DNA, we can make people superhuman almost. We can, instead of having just a tiny bit of muscle or a tiny bit of brain or whatever it is, we can give them more of that, and we can make them better and stronger than normal humans would have turned out. And should we be doing that? We're giving normal humans a disadvantage if we're making these other organisms and if we're making them better. I mean, once you guys learn biology way more in depth at school, you'll understand more about what this material is, what this DNA is, how we can just duplicate a part of us and put it somewhere that we need to. And then you guys can make an opinion. Should we clone? Should we try doing this, or is it too dangerous? I just wanted to introduce you a little bit to this concept of cloning, where you can take you or a piece of you or the material in you and just create another organism with that. Thank you guys for listening.
Thank you, Maya. It's really very impressive thing you have done. And the next time I'm going to invite Abhi to talk something about his. Sorry.
No problem. Right. Yeah. Just press present, and I think it should be good.
Okay. Yeah. There you go.
Awesome. Hi, everyone. So I'm Abhi. I am currently doing research in the Boston area, and I'll be heading to med school in July. Oh, it's fine.
Oh, it just goes automatically.
Oh, it is.
Okay. Let me start this way. Okay.
Sure. So Before we start, so like in general, I feel like this nature and science is a good way to kind of explain my path because I had a more concentrated focus on science throughout my life. And before we start into my path, I actually wanted to pose a question, which we can go to the next slide, I guess, which is how do geckos stick to surfaces without falling? And I don't want you guys to look this up. I want you to just look at the kind of images and see the foot and try and guess for now. We'll come back to it later, but just imagine if you could like go up to a glass building and stick your hands and just start climbing the building without any special like gloves or anything, right? Like how are these animals able to do this without falling off? Okay, we can go to the next slide.
Not moving.
Oh,
Okay.
There we go.
Sorry. Okay.
There we go. So in terms of my path, so in the beginning when I was very young, maybe 6, 7, 8 years old, I already had a natural interest in a lot of living things. I used to love Venus flytraps, different bugs, dinosaurs, and I would like spend time like memorizing names and watching movies about them. So my parents saw this interest and they kind of continued to culture it by taking me to places like museums where you see me here with this great shark that I'm pointing to and this bird sanctuary where I love like birds and things like that. So they heard about this NSF Science Bee when it first started, and I think the first year it actually was made, I went and I tried regionals, and I ended up placing because I was already so naturally interested in a lot of these topics that I had some knowledge. And after that first competition, I was like, wow, like this is something that I'm kind of good at. And since I'm already interested, I just kept going throughout middle school and generally doing well in regionals and nationals. And by the time that I got to 8th grade, I decided with my parents as well and some friends that we would form a National Science Bowl team. And we put in a lot of work, a lot of hours, but eventually we ended up winning nationals, and it was an incredible experience. And like NSF definitely was the catalyst for a bunch of events that, as you can see, I say like everything after, where I ended up doing a bunch of research, doing other competitions in entrepreneurship, eventually getting now to medical school. And I think the next few slides will kind of explain more in depth about how that happened. Can go next. So for Science Bowl in middle school, I did this in 8th grade. So actually the NSF Science Bees really prepared me well for this competition because it kind of provided a very broad foundation of knowledge that you need for this competition, because in Science Bowl, it's, as was mentioned previously, it's a bunch of different subjects. So it's earth science, energy science, chemistry, astronomy, biology, math, and even physics. So it's great that it's a team competition because honestly, I don't think any one person can master this many subjects. But I generally, I and one partner was responsible for mainly earth science, astronomy, chemistry, and biology. And then we kind of split the other categories based on our strengths. But here are some general resources. So similar to those on the NSF Science Bee site, there are the Glencoe Science series, and there's some specific books that I mentioned here. I think this will be sent to you guys later, so don't worry about trying to copy stuff down. It should be there later. And also for earth science and energy science and all these things, I have specific books that I really concentrated on and had to learn a lot from in order to master all the material that you needed for this competition. And also I did Science Bowl questions, not just for practice from the middle school area, but also from the high school area. And that way that I was really like, me and my team were really prepared for higher level questions that were sometimes sprung on us. We can keep going to next. So after that incredible experience in Science Bowl in high school, I was still very interested in science. And in particular, I found the brain to be fascinating. And so I decided that the brain bee would be a good place for me. Because if you think about it, like our brain is the source of all these incredible things like consciousness, emotion, who we are, right? And I was like, how does this one organ do all of that? Like, what's so special about it? And so based on that like interest, that's why I decided to kind of go all in and learn everything I could about the brain. And here are some resources that I used. And again, this will be shown after, but just very specific books that have a lot of great material that you really have to master. Also some anatomy quiz sites where you can just like select different parts of the brain and learn their names and functions. And also one really valuable thing that I started here was I started to get very hands-on. So I got to actually, with like some reaching out and stuff, handle some cadaver brain models so I can actually see what a brain looks like. Work with one professional to read MRI scans, and kind of being able to do that and kind of having like a kind of pre-med, like before medical school experience, really started me on the path toward becoming a doctor, because I was already so interested in how these different organs work. And again, I was really fortunate after a lot of work to win regionals in Brain B and then go on to play second nationally. So it was also a really great experience. Yep, and we can continue. So in high school, I also did some entrepreneurship competitions, and overall, like I learned that my passion for science never died. So I made the choice to commit to a 7-year BSMD program because I knew that I wanted to go into medicine. And it's a 3+4 program, so you spend 3 years at college usually, and then 4 years at medical school. But because of some AP credits, I actually was able to finish college in 2 years. So during this like crazy COVID year, I came back to Boston, where I was lucky to find some neuroscience research before I head to med school in July. And again, like neuroscience research has all stemmed from that one brain B competition that I did in 9th grade, where my passion for just learning about the brain just continued into research and beyond. So here's the answer to how these geckos stick to surfaces. So there's no like suckers or like adhesion glue or anything that they secrete. It's actually just based on these very, very weak attractions called van der Waals forces. So each of these gecko feet have a bunch of these rows and rows of tiny hairs called setae. And each of these hairs have even smaller hairs called septulae. And the ends of these hairs, they interact with molecules on the glass through these very, very weak attractions between molecules called van der Waals forces that are just caused by slight charge differences between them. And these forces are like weaker than like chemical bonds, weaker than like hydrogen bonds, like they're extremely weak. But because there's so many of them and so many millions and billions of hairs, it all adds up and it actually creates like an attraction effect. And scientists have actually used this model to create things like gecko tape and like special appliances that you can use with your hands and feet to like climb buildings without using any glue or like magnetism. So it's really interesting how nature has all these like incredible adaptations that, you know, we didn't design obviously because we didn't make nature, but we can learn so much from it and use it for our own technology. And we can keep going. And my last message is just, if I can do it, you can too. So I started out as a boy who didn't really care that much for school, but loved to learn about like different organisms and Venus flytraps and all this stuff. And it was just with the help of, you know, of me agreeing and my parents supporting, I cultured my interest for science throughout my entire life. And after one step to the next step to the next step, you just keep going higher and higher until next thing you know, you're where I am now. So, you know, I was just a kid like you, like I ate food, I like playing games, everything was a very normal childhood, but it was just this interest that I cultivated with me and my parents, obviously, both with as a team kind of, and a bunch of coaching as well, and taking on those resources that got me to where I am today. So that's kind of my story, and thank you for listening.
Thank you, Abhi. It was really impressive again. Let's move on to Shobha. Go ahead, Shobha.
Yeah, sure. Yeah, hi everyone. Thank you for coming today. And yeah, and also thank you to all of the other panelists. The presentations so far have been really interesting. So I had a very somewhat unconventional path to science. We can go to the next slide. Thank you. So I actually started in middle school as a national spelling bee competitor. And yeah, and I actually looked up a lot to Dr. Balu Natarajan, since he was the first Indian American to ever win Scripps. And spelling bees were kind of my life back then. But one thing I kind of learned from spelling bees was that I really liked the science words and the medical words, and I really liked how they were put together. And that kind of, when I moved to high school, that kind of inspired my first kind of interest and exploration of science. And so in high school, I ended up competing in a lot of different competitions. Intel ISEF, Regeneron Science Talent Search, and these were mostly science research oriented. And I also was a summer lab intern at University of Houston. Kamala was actually my mentor there, so lots of ties to people, but learned a lot from that experience, and it was really great. And now I have also pivoted a lot since then. I'm now studying computer science, and on a gap year from school, and I'm interning at a digital health startup, which has been really interesting. And just because I have a lot of time, I've also been dabbling in writing a book and starting my own company, which has been really fun. And then in the future, want to become some sort of health technology entrepreneur. Don't really know what idea I want to solve yet, but I mean, it all comes down to kind of that initial interest in science, which got me interested in healthcare and technology. Next slide, please. Yeah, so first thing I wanted to do is kind of talk about one of the science fair projects I did, and just kind of show you what this entire research process looks like. And I will keep it very simple, since I know that a lot of you are probably new to this subject, but most of you probably know what arteries are. They're blood vessels in your body that they basically take blood away from your heart and to the other parts of your body. And so what will sometimes happen is that when you eat a lot of different junk foods or a lot of fatty food, your arteries will start to have this plaque buildup in them. And then what happens is that this tube becomes clogged, and so blood will not be able to flow anymore, which has a lot of implications or a lot of health issues that can lead from that, like a stroke or other things. And so that's not great. And then one of the technologies that people have come up with to fix this problem is called a stent. And you can see that in the picture. It's this little metal mesh that they expand into your artery wherever the clog is, and then it will hold your artery open after that, which is really interesting. And the entire process of how they get that into your artery is just so complex and intricate. But the stent does have some problems. It can sometimes scratch your artery wall, or it'll lead to irritation. And this wall gets damaged, and that has some other problems that can come out of it. The stent might collapse, your artery might reclog. And so one of the problems that I wanted to look into with my research is, how do you make these stents less damaging? So next slide. Thank you. And one of the ways I wanted to do this is I wanted to use this computer model to basically help me simulate a lot of the different aspects of stents, but I didn't want to actually do this all with like real arteries. And one of the things with computer models is that you need some real life experiment to make sure that everything is accurate, because you don't have any sort of baseline with this computer model. So one thing that might be cool is, just for 20 seconds or something, if you all want to think about, how would you simulate that process I showed in the last slide of expanding a stent in an artery? How would you do that in real life, but you don't have access to actual arteries? What might you use for an artery? Okay, so here's what I ended up doing. I ended up getting this small little inflation device, which you can see in the middle. Basically, it uses water to expand a balloon, which is at the end of the tube, and then the stent is around this balloon. So the little metal mesh is kind of compressed around the balloon, and then when the balloon expands with the water, the stent will also expand. And then for the artery, in the next slide, I ended up using a very, very small, I think it was like 4 millimeter diameter latex tube to basically mimic what the artery would be. And I was able to kind of, for the computer model, I was able to use a software to kind of put the stent, I was able to actually put the stent into the artery, which you can see in that red box, that the little bulge is where that stent is. And then I was able to use this computer model to kind of measure how much the latex tube was expanding. And then that was how I calibrated the computer model. And then last thing, just for fun, in the next slide, yes, these are the pictures of the computer model that I created, which this is essentially the artery sliced in half. And so the scale right next to each one, you can see like blue is the lowest damage, red and gray are the highest damage. So maybe for like 10 seconds, just look at the pictures and think about which artery or which material, stainless steel, cobalt chromium, tantalum, nitinol, which of these might be damaging the artery least, which you can see from the picture. And then maybe think about why that material might be best or why that might be less damaging. Okay, so basically, just to kind of give it away, or sorry, last slide still. You can kind of see that the stainless steel and cobalt chromium are probably the most damaging because you have a lot of green and then you have some really very red spots that mean that there's a lot of damage there. The best material then is the nitinol because most of the artery is still blue, which means that it still has the lowest damage. And the reason that this nitinol is the best material is because it's the softest compared to all of these. Like all of these are very hard metals, but compared to the other metals, nitinol is the softest and most flexible one. And so what I ended up finding is that if you build stents out of nitinol, you can reduce the damage it has on the artery. So for patients who have a history of this type of complication, where their artery wall is very damaged, then using these nitinol stents can help reduce that risk. So that was essentially the project I did. And next slide, please. I know that this sounds very complicated, or it might just sound like a really long process, and it was. But this was basically an entire year of work, and this was after a lot of trial and error on my own part to just learn more about how to do research well. And definitely possible for you to do it too. And here's just some initial tips that I have. First of all is just to find a project idea. The way I did it mostly is by doing my own research and reading about different literature and science research that was happening. But you can also volunteer at a local university lab. You can also do some summer research programs, and you'll be able to work with professors, or you'll be able to find a project idea that way. And then the second thing I would say, just in general, I think this applies to any science competition you want to do, whether that's Olympiad, Science Bowl, or science fairs, is just to stay updated with what's happening and with what the latest research is. And then some books that I would recommend, or some resources, is the first one is called Success with Science. I read this when I was in 9th grade, and it really helped get me interested in science fairs. And then to just learn more about science, I think that Science News for Students and Science Daily are also just really good resources. And then there are science fair competitions for 6th through 8th grade, which is called Broadcom Masters. And then there's also competitions for high schoolers. So that is like the Intel International Science Fair and some other competitions as well. And then the last slide is just kind of like, why should you do science? What do you get out of it? And so the main things I've gotten are, one, the communication skills. I learned just a lot about writing and speaking from doing science and communicating what I've learned. I also learned that I really like doing things that have real world impact. Pretty much every single research project I did, I could kind of see how this could lead to a real world impact down the line, or could tie it back to someone I knew, even in most cases. And so that was really, really exciting to me. And then also just experimenting, testing, validating everything that you do, having control groups, not coming to assumptions very quickly, but making sure that the data you use supports what you're concluding. That's really important for science. It's also really important for entrepreneurship, which is another interest of mine. And that kind of ties back to problem solving, is using data to answer your questions, guide your next actions. And then the last thing I would just say is kind of a general life lesson is failure, and being able to learn from failure, how to pivot when you do fail, and how to get back up and keep going even when you're not getting the expected results, or when what you thought was going to happen didn't happen. And I think that that's something you learn from science that just applies to every other aspect of your life. So yeah, when we get to the Q&A, happy to answer any other questions about this. But yeah, thank you again so much for your attention.
And thank you, Shobha. It's a really interesting topic. Next, I'm going to invite Bhagirath to, let me make him as a presenter now.
Okay, I can't share my screen because MacBook's not giving me the permissions to do so. I think I'll have to leave the meeting and come back to do that.
Okay.
I can.
Okay, you are the presenter, but yeah.
Sure.
Yeah. In the meantime, we'll go ahead with any questions.
Sure.
And Kamala, that's your. Sorry.
Can I just quickly tell everyone that I'm going to need to drop off in about 5 minutes. So if you have any questions specifically for me, you should probably ask now.
Yeah, I put up a message also. Yeah. Can you see the screen, Kamala? No. No?
Yes, I can see it now.
Okay.
Hi everyone, welcome to Science Pro session. My name is Kamala and I currently work as a senior scientist in University of Houston, Texas. So I'm a cougar, go Cougs. So I came to United States in 2016 to do my master's in medical microbiology at UTD, and after that I worked at UT Southwestern for about 6 years, and now I work at University of Houston. So throughout my life I have been in science, but my main focus of research was mostly in autoimmune diseases and bladder cancer research. So I started volunteering, or I was actually thrown to volunteer in 2006 in NSF by my sister, who was one of the key organizers of the Dallas chapter. At the beginning, I was thrown, but later I really started enjoying how a team of people organize such big events. So at that time, I was a student, and so I didn't know much about the material or how valuable it is for a student. But later on, again, in Houston chapter, when I got involved, I have like 2 kids. One is a 3rd grader and one is kindergartner. So when I started taking my 3rd grader, that's when I really realized how valuable the material of NSF science chapter is. If you go to the next slide. This is an example. I didn't want it to be very elaborate. So this is one of the example I got from the workshop. So it's very difficult for the kids to remember like what's the distance, 4,498 or something. So this is one of the table that a science workshop has taught my 3rd grader. And it really helped him when he answered the questions, not only in the junior science B, but also TMSCA and international academic competition. So this was like a catalyst for me. I took this as an example, which I got from NSF workshop, and I made like similar tables and flowcharts for animal classification, plant classification, animal, divide it into vertebrates, invertebrates, and create a mnemonic. All my best friends represents vertebrates, which represents the 5 parts of animals. So similarly, I did so many, and I put like a flow, I printed them out and I put it in my son's room so that he can just look at them in a day. So all these ideas started from the NSF workshop for me, and this gave me confidence to be a coach. And I coached for junior science B, and I go to the next slide. Next slide, please. And this is one of the books that really helped me to have a complete picture rather than following like multiple websites where I don't know whether it is true or not. And so this website this textbook has very good information for the junior level until 6th grade. It is good. I believe until 5th grade it is good for competitions. So apart from this, I also have followed everything you need to know about science, and B Star, which is also very good. And in Texas, we also have one of the competition, TMSCA. TMSCA also gives us a lot of information and material for science competition and math competitions. So so to sum it up, NSF helped me a lot how to guide my 3rd grader in all aspects, not only in science, but in all aspects. That would be all.
Thank you very much. It's very impressive. Looking at parent point of view also. Before I go to Bhagirath, there are a couple questions for Maya. You're still here?
I'm still here.
Okay.
Yes.
One of them is asking, how did you manage your time for those competitions along with the school work? And what are you planning to do in the next years in the high school?
Well, how I manage my time is I created a kind of schedule. I decided that I block off a certain time section to do my schoolwork, to do my homework, and then I'd set like an hour each day to study for science, and then on weekdays a little bit longer than that. So I'd always have a schedule, and I'd always know what I was supposed to be doing at some point in time. And then the second competition, not the second competition, the second question, I'm not quite sure yet. I'm still looking into my interests. Since I'm going to be going to college soon, I'm thinking I'm going to look at all the branches of science and figure out the one that I'm most interested in and start learning more about that, find some topic that I'm interested in that I might be able to do research. Because I need to start specializing so I can know what I want to major in, what I want to really do with my life.
Okay. Thank you. And they are asking for some specific books you would recommend for physics, chemistry, biology, and so of 7th grade, which I think our other panelists can pick it up also.
Yeah, I think it'd probably be better for specific books for physics, chemistry, and biology. I studied from general science books, but I split them up into topics myself, and I studied from some articles online. So you should probably ask the other panelists for specific textbooks.
Thank you, Maya. Unfortunately, Maya had to leave for a class scheduled at 1 o'clock. And so we will excuse her, and then we will continue with the rest of the panel. Bhagirath, can I?
Talking to you.
Thank you, Maya. Thank you for coming. And Bhagirath, are you okay? Can I put you as presenter?
Yeah, can you give me permission again, please?
Yeah. Do you get it?
Yes. Can you see my screen, the presentation?
Yes.
Okay, awesome. Okay. Hi, everyone. Thanks so much for joining us, and thank you to all the other panelists, and to Dr. Vijay and Natharajan for organizing this, and Dr. Vanarsa. So I'm Bhagirath Mehta. I want to start by sharing a science question that you guys can think about in the back of your head. So what is the longest possible vertical straw that will work at sea level? And you can make any reasonable assumptions you want about this question. And over here we have a person who's flying, so we can just pretend he's Superman. So even for Superman, there is a maximum possible longest possible vertical straw that he can use, and after that the straw will stop working. So think about that question in the back of your head. In the meantime, I want to go through my path in STEM. So very similar to some of my other participants and co-panelists. My path in STEM just started from a young age where I was constantly learning. So I was always asking questions about the world, trying to read and understand more, and then go deeper into these concepts. So for example, when it came to riding my bike, I wanted to know how far I was going. And so my dad taught me about circumference, and then he told me to measure the rotations of my wheel, and I could multiply the circumference by the number of rotations to calculate how far I've gone. And I was a library baby, from a very young age. I was always spending my free time there, checking out books on various topics. I also went to tons of museums, and it wasn't, just about clicking buttons on the displays, but actually reading it and trying to understand the exhibits there. And I really love going to labs. So there are 2 national labs near me since I live in the Chicago area, Fermilab and Argonne National Lab. And both of those labs had open houses every once in a while, and so my family would always make sure to go. And of course, NSF really started my journey. So I think I started participating in 1st grade, and in 2nd grade I won 1st place in the Math B Level 1 competition and 3rd place in 4th grade in Math B Level 2. I also participated in the spelling, geography, and science Bs, but in 4th grade, after 4th grade, my dad was very involved in the core team, so it would be a conflict of interest for me to keep participating in the science B. But I continued through other science competitions. So in 6th grade, I was the national challenge winner for the Be the Chemist. And I continued my STEM journey. I was 4 years ahead in math, so in 8th grade, I got a perfect 5 on the AP Calculus BC test. In 9th grade, I won a perfect score I was an international winner with a perfect score in the Math Kangaroo competition. And I participated in biology, chemistry, and math Olympiads. I was an AIME participant every year of high school, and also a national semifinalist for biology and chemistry Olympiad. And though it's not quite science, I also was able to publish a social science paper in a prestigious journal called the Concord Review. And I would really credit my research skills that I developed and honed through all my science research that helped me publish such an intricate paper. So to continue my path in STEM, in high school, I founded a club called 3D Innovations, and we use technology and all the available tools and gadgets and computers at our school. So we had a 3D printer, and we had a classmate who was unfortunately born without a right hand. So one year we printed a prosthetic hand for him, and were able to give him a prosthetic hand for the very first time. Another year, we worked on building a model of our skull that was tactile. So, when you touch it, it would light up and give you directions to certain places in the skull. And this was to help visitors and also a student at our school who was visually impaired, because our school was not prepared to help her needs. I was also interested in just giving back generally. So 3D Innovations was a way in which I did this. I taught a website bootcamp, how to make websites to middle school students. And because there was no NSF coaching available for some of the competitions that I was participating in, like You Be the Chemist, I launched my own startup, Meta Plus Tutoring, where I was actually able to help a fellow student win 2nd place and the Be the Chemist competition when he participated. And over the past few years, I've been teaching boot camps on machine learning, artificial intelligence, and app development. So I'm just continuing that path in order to get forward. Okay, now I want to ask all of you a question. What makes a scientist? So there's a great quote that my AP chemistry teacher always used to say in high school. It's all about exploring the unknown. So a scientist who wears a lab coat and is just conducting the same experiment for the 1,000th time, already knowing the results, that person's less of a scientist than someone who just takes apart a motorcycle engine and is trying to explore the unknown and discover something new. So no matter how silly or zany or crazy it might seem, as long as you're tinkering and taking things apart, it's science. Okay, so how can you proceed further in your science path? So you've checked out all these books, you're curious, you keep reading. So competitions, of course, are a great way to keep moving and be motivated. And I think that's why we're all here today. They're not the be all and end all. Certainly, they're just a means to an end in order to motivate you to learn more, or like it gives you some kind of concrete goal that pushes you forward in your science journey. But it's a great way to get started. So check out what's available to you in your area and ask your teachers and administrators for help. Sometimes there's clubs or activities that are available. Maybe they're targeted towards older students, but you can always ask to join, even if you're a younger student. Maybe some competition isn't available at your school. You can ask to get it started. You can start a new club. So the sky's the limit as long as you just ask for help. Okay, so for the Be the Chemist challenge, you know, the path might have changed in the past few years, especially after the pandemic. But the way it worked for me when I was participating was at the school and regional level. There was one packet, you know, like it was like a 55-page packet, the beginning packet. Then there was like a 110-page packet that was added, the intermediate packet for the state level, and then a third packet for the national level. So, you know, why do I mention this? You know, is it because I just said, you know, I'm going to read these packets and boom, that's it? Well, no, of course, right? You know, you want to continue, once you get really familiar with the basics, go above and beyond. So, you know, you have to check out different websites, online, books, DVDs. If any of you are familiar with the, you know, Dewey Decimal System, 540 is the series for chemistry. So I was very well acquainted with that series and probably had, you know, at least half the books from my local library at home from the 540 series. So I have a list in my presentation of books and DVDs and websites. So Dr. Vijay can share that with you later. But you know, some of the ones I wanted to cover were there's some cuter books, like, you know, the periodic table Elements with Style was one of my favorite books, because there were, you know, various elements covered inside the chemistry packets, and I just really wanted to ingrain that knowledge and just knowledge about all the different elements on the periodic table inside my head. And the periodic table kind of, you know, anthropomorphize each of these elements to give them a little personality. And I think that really helped drive in knowledge about the periodic table. You know, and these books, they definitely go above and beyond than what might be necessary to you know, participate in a competition, but you know, it gives you so much background knowledge. It's so interesting, you know, just understanding, for example, the creation of the periodic table on the right, or, you know, reading like a cartoon, you know, comic book about chemistry is always fun. So these are some fun books. You know, some more serious books. So The Elements by Theodore Gray, you know, really gives a beautiful visual exploration for every element. You know, Understanding Chemistry by C.N.R. Rao, and Chemistry for Dummies. So these are just, you know, an overview of the books. Of course, you can, you know, go into like whatever books interest you and are available to you locally. Maybe you want to study mixtures. You know what a mixture is? Okay, great. Like, you know, how many types of mixtures are there? How small are the particles in a mixture? You know, try to understand each part of that deeply. And so you can even, you know, start with, you know, a picture book on mixtures and, you know, work your way up to like textbooks. So I find that once I'm, you know, ready, I feel I'm ready for, you know, my current level. It's always helpful to prepare for like the next level. So I checked out books on AP chemistry and, you know, the SAT chemistry test, and that really helped, because it not only gave me practice questions, but it prepared me for above and beyond what I needed. And, you know, there's other textbooks like Atkins Physical Chemistry, although that's certainly very high level, and, you know, that's for the Chemistry Olympiad. So definitely, you know, would not recommend starting there. You know, there's also some fun DVDs, Squibs, Bill Nye, Eyewitness, and then, you know, some much more informative DVDs like from Schlesinger Media, The Great Courses, The Joy of Science, Nova, Smithsonian, Discovery Communications. So yeah, I've put a list of all these resources in the presentation. And, you know, there's also a lot of great websites, because you want to keep practicing. I check out practice questions. So not just for science, but also for math. A lot of these websites are great. You know, and just the same approach that I put towards finding books for math, I would recommend doing that as well. You know, like maybe check out a mathematical dictionary in order to understand different terms. Geometry is something, and like word problems are not, you know, necessarily covered in school well. So definitely check out books covering those. So, you know, my final tip is learn more. You know, always shoot for the stars, because if you miss, you'll still make it to the moon. And what I mean by that is, you know, for my competitions, it wasn't really necessary for me to memorize the periodic table, but I did anyway. And it really helped, because in the national level, you know, for the final round, it was me against the eventual second place winner, and I had basically already won because I had answered more questions correctly. However, I had still received one question incorrect in that round. So I went to the judges and I appealed it, and I told them that this chemical is available in this column in the periodic table, and this chemical is found in this other column, and so that's why I think my answer is correct. And so they overturned the answer, and they gave me the correct answer to that question. So I want to go back to the problem that I posed at the start. What's the longest possible vertical straw you can have? And so what's the answer? Well, it's 10.3 meters. but I hope that you don't think, oh, okay, that's it, right? Great, we're done. I hope that's not what you took away from this presentation. The question should be, why is the answer 10.3 meters, right? This is just the starting point for our learning. So first of all, it's kind of strange to think that there is a maximum possible straw, right? I mean, maybe Superman has super powerful lungs, right? Why can't he suck the water even up a higher straw? Well, the answer is that suction isn't exactly like a positive force, right? What suction does is it creates a partial vacuum at the top of the straw, and the surrounding force from the differential in pressure forces the water up the straw. So this is similar to how a barometer works. If you know the principle, basically the surrounding pressure here is constant. It's like 1 atmosphere, and because we are reducing the pressure in the top of the straw, this creates a vacuum at the top and a pressure differential, and that's what causes the water to go up. So how tall can that column of water possibly get, right? Like in a barometer, you can measure based on the height of the water, what the pressure is that day. So let's actually do the math. So outside the straw, we have 1 atmosphere of pressure that's pushing down on all the water. Inside, what's the lowest possible pressure we could get? Now, my lungs are not Superman, so definitely I'm not getting a perfect vacuum in here. And I don't think it's really even possible to get a perfect vacuum, but let's just say we can get it all the way down to 0 atmospheres, right? There's no pressure. That's not really realistic because the water would evaporate, but let's just pretend we have 0 atmospheres. Okay, so now let's go through some equations so that we can actually apply them. So we want to balance these forces, right? We know that the force is coming from the differential in pressures, right? And we know that that force has to be enough to overcome gravity. Okay, so force equals to mass times acceleration. We know we can figure out what our mass of the water is later, and we know the acceleration has to be g, or 9.8 meters per second squared. It has to overcome the force of gravity. We can calculate then the mass of the water from the volume and density. So at standard temperature and pressure, our density of water is about 1 gram over centimeter cubed. But we don't know our volume either. So our volume is equal to the height of the straw, right? The maximum height times the cross-sectional area. Now we don't know our cross-sectional area, but you'll see in a second why that's fine. So we have one force that we need to get, right? That's the mass times acceleration. We have to balance it with the other force, that's actually driving this action and set these equal. So how do we calculate that force? Well, we know the force is derived from the differential in pressures, right? We have 1 atmosphere here and 0 atmospheres inside the top of the straw. And so that pressure equals to force divided by area. So we can just rearrange that equation to get force equals to pressure times area. Okay, sorry, that was a mouthful, but I think we have all the equations we need to solve this. So I'm just going to start out by saying force equals mass times acceleration. I'll plug in the equation for mass inside this, and then equation for volume I can plug in for that. And so now I get force equals to height times area times density times acceleration. So I know what my maximum force that I need is, and then I also know what my force that I currently have is, which is pressure times area. So I can just set those two equations equal to each other, and area cancels out. So as you see, we don't really need to care about the cross-sectional area of the straw. And so we just get the maximum height is equal to the pressure over density times acceleration. So if you actually plug in some numbers, for gravity, we have 9.8 meters per second squared. I plug in the density of water, and at standard temperature and pressure at sea level, we have 1 atmosphere as the pressure. And if you go through the math, you'll see that the maximum height possible is 10.3 meters. So I know I ran through a lot of science quickly. I hope that you'll take the time to actually read more about some of these concepts, how a barometer works, reading through some of this math, working through the equations on your own, trying to derive this answer yourself. But once you do that, you can just keep going further, right? Like, what if the liquid that we're trying to drink is not water, but mercury? I mean, don't do that, but just imagine, given the specific gravity of mercury, what is it? So and what if the straw were partially submerged in the water? Would that change anything because of the added pressure of the water? Spoiler, it would. But I would encourage you to find those equations on your own, understand those concepts on your own, and figure out what's going on. And if you want to email me about it, I'd be happy to chat. So I just want to end my presentation by saying thank you so much for this opportunity, and good luck to all of you participating.
Thank you, Bhagirath. And Balu or Kamala, you start announcing the questions? Or
Absolutely. I do want to, I'm paying attention, right, to what everybody's saying, and I figure if I can get Dr. Kamala in a lab overseeing Maya, Abhi, Shobha, and Bhagirath, there's a lot that we could do, right? So, but the one thing I need is hair, which I don't have. So I would need Maya, right, to help me clone what I've got. And then I could get longer because the Nitinol that Shobha already is using would help with hair extensions. And if I can get Bhagirath to get me a third prosthetic hand, I could comb that hair and get enough of it to get me van der Waals forces, which would allow me to actually climb buildings and leap them, which is totally outrageous. But if you think about what our speakers have presented and what they've done in each of their ways, right? Think of the possibilities if we put it all together. And in a vicarious way, right, we've virtually done exactly that. We've brought all these people together, and it's absolutely fascinating and exciting to hear what everyone here is doing. And we're just getting started, right? All of you are, besides one, right, all of you are somewhere between high school and college, and it's just super cool and really a treat to observe what you're teaching all of us. So there is a question for Abhi. This is a personal question. Somebody's asking where in Boston you went to school. So we'll start with that real simple, and then we'll get into a little bit more heavy duty stuff in the time we have remaining.
Sure. So I went to Doherty Middle School, which is a public school in Andover. And then for high school, I went to a small private school called Pingree High School. So they're not like especially well-known schools or anything. So a lot of my work was like outside of school, I guess. So it was a little bit different for me, but yeah.
Very good. Bhagirath, there's a question on the periodic table. Are there any tricks that you have to memorize the periodic table?
Yeah, there's a, so, you can make your own mnemonics. Certainly, I think there's something like Harry, he likes bottled beer, something like that. So certainly look up, mnemonics. I made my own up. My sister helped me out with those. So it's always good to practice with a friend. And there's a site called the University of Nottingham. They have these like the video of the periodic table of elements, and so they have a specific video for each one, and it just the way that they describe each of these elements and give it all such a colorful personality, and they do an experiment with each of these elements that invariably ends with something being blown up. So I mean, it's so much fun that you will like definitely have the periodic table just burned and etched into your memory.
Shobha, we didn't get this question formally, although we talked about it previously, and I think it's something that is interesting to folks. You have spent time in language arts, right? You've done well in the spelling world, and your family has definitely contributed in that regard. How does one lead to the other, right? So spelling to science, and then does anything loop back, right? Because we have heard from so many of you, right? Some with brain bee, some with math, some with science. You've done things in non-STEM fields. How do those worlds connect, if at all? Because obviously at our foundation, we're trying to build holistic learners and holistic leaders.
Yeah, I actually wrote my college essays about this, but I think with spelling, like I mentioned, I just found that I really liked a lot of the science words, the medical words, and just how they were put together. And so that was kind of how I first decided to start getting into science, was because I thought those words were interesting and kind of wanted to explore them more. And then I also think that spelling really helped with science and just everything in the future. It kind of all comes back to the life lessons I was mentioning. How do you deal with failure? You don't win every spelling bee. Not every experiment works. How do you bounce back from that? And what do you do? And kind of that taught me to view failure as kind of a learning opportunity rather than just kind of, this is something to be sad about. And then I think the other aspect of it is that I guess another thing that I'm really interested in lately, especially going to school in Silicon Valley, is entrepreneurship. And I think that spelling and science, kind of those life lessons, also tie into entrepreneurship. You're doing a lot of failing fast and testing things out before things will actually work sometimes. And science especially, I think I learned a lot about how to experiment, how to analyze data, how to do an experiment very quickly, and then get what you need out of it and set it all up in a very structured way. And so that's really helping right now with the startup I'm building, because I do have to set up some experiments really quickly and work with people to get the data that I need, and then that will guide what I do next, essentially. And so I think everything kind of life lessons wise ties together very well, but also there are some hard skills in there that are very interrelated between all of these spaces.
Excellent. Lots of questions in the chat box about websites and links and things of that nature. Dr. Vijay, you will be sending out a summary, right, with lots of links in them, correct, sir?
Yes. Yes. Tomorrow we'll be sending the link for the recorded version of this, as well as all the presentations they have made. There will be links. So don't feel bad that you didn't note it down anything or grasp anything, but you'll have it in your hand tomorrow, probably by around this time.
Good. We don't have a lot of time left. There's a question. I'm going to ask a broad question, right, and then we can have our panelists respond. You're all welcome to respond. And so the question, it's kind of a two-part question. The first part is, how are you able to balance, right, competitions along with your schoolwork? But I'm going to add a second part to that, which is, what is the best way that your parents can support, right? Because the definition of parental support has evolved across countries and across generations, right? So what worked for my parents halfway around the world, 50 years ago, right, or 70 years ago, is different necessarily from what works today. So we need to hear both parts of that answer from any or all of you, please. Abhi, you want to go first? Are you good?
Sure, I can go. So I would say, so first, in terms of like what is good for a parent's role, I would say first thing is to understand the child's interests and get them to try new things. So once they try something new, I think it becomes pretty obvious whether they like it or not. But like I know with me, especially like the first science bee, I was very hesitant because like I just liked learning and not competing. But I think that push to just get me to try it once is what triggered the rest of this. So I guess that would be the answer to that part of the question. And in general, I think one huge thing that is like once they realized my interest and I was kind of self-driven, they helped me find all of the resources to like keep learning. So like all of the books, websites, like a lot of that was my parents who like spent a lot of time talking to people and looking for places, because I was very young at the time. I didn't know where to find a lot of that. So I guess those two things would be what I would say.
Great. Bhagirath?
Yeah, it's difficult certainly to manage schoolwork on top of competitions, but I think that especially in your younger years, the homework load is pretty light, so that gives you the time to explore a lot and do tons of activities. And you can always multitask, right? Like when you're going out for a walk, you can bring a book with you. So that way you can always keep learning. Plus, once you start on this competition path and you're preparing for math Bs and science Bs, automatically your math homework, your science homework will be much, much easier. So that will, in some ways, save you time in the long run. As far as parents supporting, I can't ask other parents to do this, but I can say that what my own parents used to do. Certainly, like every time I have like a question about a certain subject or test, right? Like the next day when I would get home, I'd see all these books waiting for me, or if I had a question for my homework, I'd be stuck on it for a long time, and then finally at midnight I would just go to my dad and say like, I don't know what I'm doing here, and so he'd stay up at night, read the entire textbook, help me out, and then like at 3 a.m. wake me up and like teach me, so that I would have a clear understanding. So as a parents can always continue to support their kids in terms of like encouraging them to do whatever is necessary when the going gets tough, but at the end of the day, to some extent, we need to as kids also appreciate our parents and make sure that we're always interested in you know, and self-motivated in what we're doing, and we keep this joy of learning to you know, just constantly get our understanding clearer and clearer.
And so I heard Abhi saying, right, as a parent, look for the spark, right, and then nudge in the direction of that spark. And Bhagirath, I heard you saying that you worked hard, and then when you hit a wall, your parents got you over that wall. And I also heard you saying interesting things like studying with your sister or asking your sister for mnemonics. So you made a fun family affair out of it. It wasn't oppressive, right?
Right, yeah. No man is an island. And, yeah.
And Shobha, anything to add in that regard? I know that your family has done a lot of things together, certainly in the spelling realm, and I would imagine beyond that in STEM as well.
Definitely, yeah. I think I very much agree with what both Abhi and Bhagirath have said. I think just the general thing that I think my parents did really well is that they definitely let me explore a bunch of different things, and then once they found that I was really interested in the space, kind of helped me to specialize, basically exactly what Abhi was saying. And I think the other thing they did really well is that they let me make mistakes on my own. They didn't kind of they didn't, like, whenever they saw me running into something, they'd let me figure it out and then come to them for help. So a little bit more of what Bhagirath was saying there. Like there was one time where I was doing a science fair project, and I was literally like playing with cow intestines and trying to like put them together to test calcium absorption, and it was an entire project. And my mom was just sitting there and like waiting for me to ask for help before to kind of set the entire experiment up. And I think that just really summarizes what my parents did, is that when I was having issues, they kind of let me figure it out for a while, and then but they were very open, and where they would always tell me if I needed help, they were there for that, and they would definitely help me with however they could. So I think there's a really fine balance there, and I think that they did that really well.
Okay, I have a quick question, which is a one-word or three-word answer from each of you. Do you all participate in other activities such as sports as well? We'll start reverse order. Shobha, you go first.
Not strictly a sport, but I do Bharatanatyam, Indian classical dance. And then I used to play viola. I don't do that very much anymore, but every once in a while, like it's right there in my room, and so I'll pull it out and just practice. So yeah, hobbies are definitely great to have.
Right, Bhagirath.
Yeah, yeah, definitely lots of music, piano, violin, singing, volunteering activities, and I'm a huge fan of belaying and rock climbing. So yeah, I took some classes at the Y.
Awesome. Abhi.
Yeah, so I did cross country for a long time, and I also played piano, and I'm still trying to gain back all the weight I lost in cross country. So.
Cross country running, cross country skiing?
No, like running like for miles and miles and miles.
All right, so you run these days, what, 30 miles a week, something like that?
Well, now I don't run because I'm just trying to gain back the weight. So.
All right, very good. Good problem to have. And so my last question. Now, there are some other questions here we did not get to. I may ask Dr. Vijay to send that to you as panelists, and if you can respond, we'll just put that right in the group responses, because some of them are nice questions to be able to get some answers out.
Yeah, exactly. I was exactly thinking the same thing. So we have so many questions, but we may not be able to get it now, but I will always get it through, answer all of them to answer, and then send an email to all those who are here.
Excellent.
So that'll be good.
And I'm going to ask Kamalaji a question to answer before I close with my closing slides, and that is, you referenced, right, the third grader and how you learned quite a bit, right, that helped you at home. I think that if we look at our other panelists, right, Dr. Krishnan Gauri is here, Dr. Desi Vijay is here, right, we've all got kids, and our experience has been, you know, that when we give, we gain so much more for ourselves as human beings, and we gain so much more for our own kids. You know, in Bhagirath, right, he even mentioned he wasn't able to participate because his dad was a member of the core team, yet the reality is he's done just fine, right? So can you speak a little bit more to that, because we have lots of interested parents on this call, and we could use their brains and their interest, right, in helping out so that we can deliver more for all of our children, both here and in the United States, here and in India. But I'd just like to hear a few additional thoughts on your side.
As a parent, like, although I was in science for 12 years, the way and the resources, the method of teaching and the resources, I wasn't aware of. I knew like the periodic table in and out, and I knew OChem very well, but I didn't know the method of teaching. I can't make a 4th grader or 5th grader sit and memorize it for 12 hours a day, and within a month he will forget it. So when I started volunteering and when I talked to the organizers and everybody, I got a bit of idea. Then they encouraged me to become a coach. The Houston chapter, one of the key organizers, he gave me some books, Mr. Sai Rachakonda, and he encouraged me to be a coach. So that was my first step. And I don't know how much I taught, but I learned a lot from the coaching. In fact, I went to a method after a couple of classes. I didn't like those slides, so I made my own slides because I thought that was the easier way. I didn't want mainly the ecosystem if you take. I thought it was jumbled up. So I made my own one slide, biotic, abiotic, and that's it. But it depends. Some parents didn't like, they wanted 18 to 20 slides, but I got everything in one slide.
You simplified it.
Yeah, so this helped me to teach my kid in 20 minutes rather than making him sit for 2 hours. And in lab, I teach a lot of undergrads and high school students. Like, we learned a lot from, when Shobha was interning in our lab, I got to know much about spelling. And I enrolled my kid into the spelling and he won. Shobha gave me some tips. So interacting with high school students also helped me learn. So everywhere I go, I see and learn. And that helped me grow and also put that in, help me grow myself and also like my kids. So I encourage all parents, like just as a parent, I want to make this statement. If you just put them somewhere and pay the fees and let them get the coaching, I don't think it's enough. We need to do our part also. I have 2 kids. My elder one is really bright, and he's anything sitting and doing arts, piano, reading, math Olympiad, math league, he can do. You ask him to go and play basketball, he wouldn't do that. But it's vice versa for my younger one. He just jumps all the time. You ask him to hold the pencil, he doesn't do it. So like Abhi said, we should see the spark and we should encourage them in that direction. So my younger one is completely in sports and I am struggling hard to make him learn 2 + 2. So as a parent, I would say that we should see where our kid stands, give them the taste of everything on the plate, but let them master like what they are really good at.
All right. Well, we can talk later because basketball statistics might be the way to create that link for the second one. We can talk about that at a different time. But meanwhile, Dr. Vijay, if you don't mind pulling up my slides, because I have made us late, but I hope that this was valuable. I am absolutely stoked and excited. Dr. Gauri is texting me behind the scenes saying this was one of our best sessions ever. And I totally, totally agree. This was great. So many, many thanks to Maya, who's no longer here, Abhi, Bhagirath, Shobha, and Kamala. Thank you so much. And I'll close it out with a few slides.
Can you see now?
I can see. Thank you very much. So just very quickly to all of you, we appreciate so much that you are joining. You know, what we're recognizing over the years is that success is not a flash in the pan. It is, if you can go to the next slide, it really is a marathon. It's not a sprint. And we have a wonderful schematic here. If you're able to expand the slide, that would be nice. If not, that's okay. If you can hit presentation mode. That's all right. We'll just go with it. But we can see at the top, right, there are those 3 bars. It says empathy, education, and excellence. And we've started what we do really totally empathetically. We want to try and support those who don't otherwise have access to basic education. And we can see, right, how that then turns into things like Shobha and Kamala comparing notes so that they can serve their own children and other children. And what we do is knowing that everything that we do helps a cause of either children who can't afford devices here in the United States or college tuition in India, then everything that we're doing, right, has a higher purpose. So you can show up at our prep clubs and get coaching, and then you can come to a workshop where you get some practice, and then you go to our contests and you see how you're doing and you get your award. Maybe you place in a first or second or third, but if you don't, that's still actually just fine because you're learning through the process where you stand. And then you go right back through the cycle. You get more coaching, you get more practice, you get more workshops, and then you do it again. And what we've seen is those children that stick with us for many years, they all do incredibly well, not just at North-South Foundation, but beyond. So next slide, please. If you want to be a quote success, like all of our panelists, no matter what you do, I think we've learned, right? The effort gets you somewhere in life because there are soft skills as well as the tangible things that you learn. We can go to the next slide. If you want to get that practice, you can get it in a couple of places. We still have one more workshop for Intermediate Science B. That is next Saturday. You can find that on our website, but we've also got our online regional contest. There are 2 weekends. One is the second weekend of April and the other is the first weekend in May. Again, you can go to our website and you can sign up for that. Just an incredible value with the money going to support education in India and in the United States for those who cannot otherwise access it. My thanks to all of our panelists. Next slide, please, Dr. Desi. Remember that success is a marathon, not a sprint, no matter what we do. My thanks to everybody for participating today. Wish you all the best. Take care.
Thank you.
Thank you, panelists. Thank you.
Yeah, thank you, everybody. And it was really a great session, like Wallace said. In fact, after I listened to you, I think I have wasted my life. I haven't really done anything. You guys have really done so much. Thanks, everybody.